Welcome back to my channel. Now, as we draw closer to exam week, I would like to give some attention to a few physical geography topics. In the last video, we talked about the different climatic regions of the world. We talked about climate change. We talked about different weather systems in the Caribbean. And we spent a lot of time talking about the tropical marine climate. Now, one of the things we said about the tropical marine climate is that it is made up of a wet season and a dry season. Now, this climatic pattern will also influence the hydrological cycle or water cycle. The hydrological cycle or water cycle describes the continuous circulation of moisture from the atmosphere to the surface and back to the atmosphere. In the wet season, rainfall dominates weather conditions. Under such conditions, soil moisture and groundwater storage will increase, and this will cause the water table to rise. In some cases, the water table can also rise to the surface, creating ponds and lakes. Of course, these are usually temporary. Since surface drainage is also supplied by rainfall as well as overland flow and groundwater flow, river discharge will also increase during the wet season. Sometimes the increase is so great that it results in flooding. At high volumes, the river's competence and capacity will increase, which means that the river has a greater ability to transport larger materials as well as more materials. The process by which larger materials, such as boulders, are moved along the riverbed is called traction. As traction occurs, the river will abrade the bed, contributing to the development of a number of landforms in the upper course, including V-shaped valleys, interlocking spurs, potholes, rapids, waterfalls, and gorges. If you are interested in learning more about these landforms, I will leave you a link in the description box. During periods of high discharge, the process of hydraulic action will also increase. This is a process by which the force of the water itself erodes the channel. In the middle and lower courses of the river, most of this force is concentrated on the banks. And because the channel along the middle and lower course is mainly meandering channels, most of this force is concentrated on the outer bank where the river flows faster. The inner bank on the opposite side will experience a slower speed of flow, and therefore with a general lack of energy, deposition will occur, leading to the formation of slip-off slopes and point bars. It is also during periods of high discharge that oxbow lakes usually reach their final stage of formation. The oxbow lake is a curved lake formed when a meander is separated from a river channel. Let me say that again. The oxbow lake is a curved lake formed when a meander is separated from a river channel. As time passes, meanders become more winding, and the outer banks get closer and closer together, while the inner bank continues to deposit materials. Under flooded conditions, the river breaks the narrow gap which separates the two outer banks and begin its flow as a temporary straight channel. The silting or deposition on the inner bank will finally seal off the meander, and this is what will create the oxbow lake. Now, another type of landform that is associated with the wet season, especially when flooding occurs, is the floodplain. Floodplains are named because of the fact that flooding occurs. Now, floodplains are the result not only of deposition but also of erosion. Lateral erosion will remove spurs, creating flat areas of land, and then during periods of high discharge, deposition will occur and build up this flat area of land. When the channel is unable to contain all of the water that is flowing through it, the water will overflow its banks, and the largest materials will be deposited first. Now, when this happens, it will cause the banks to be raised, and this will create features known as levees. The smaller materials will then be carried further away from the bank and onto the floodplain, and this is what will build up the floodplain. Now, what about dry seasons and the water cycle? In dry seasons, we usually have more evaporation and transpiration. In the absence of rainfall, the water stored in the soil is used up. If there's a long period where rainfall is absent, the water can be used up so much that it creates a soil moisture deficit, and this is very bad for farmers. Additionally, the water table will fall. Discharge will also begin to fall in surface streams, and this will reduce the river's competence and capacity, as well as their erosive ability. Under this condition, materials carried down course during the wet season will now be dropped on the river bed, because the river now lacks the ability to continue to transport them. This leads to the development of some small islands within the channel, and it converts the channel into a braided channel. Surface streams mainly develop in areas of high relief where the rock is more or less impermeable, so that instead of the water infiltrating into the ground, it flows over the surface and over time begin to carve out channels. Besides fluvial erosion, other processes of denudation usually occur in these highland areas. One such process is that of landslide, which is the sudden and rapid movement of materials downslope under the influence of gravity. Landslides can be triggered by both natural as well as human activities. They can occur both in the rainy season as well as in the dry season. However, they are more common during the rainy season. Where a thick layer of unconsolidated materials, such as sand, clay, or volcanic ash. By the way, when we talk about unconsolidated materials, we're basically talking about loose materials, and that is as opposed to consolidated. All right. So when unconsolidated materials occur along a slope, and they become saturated during periods of heavy rainfall, landslides are likely to occur. What happens is that the water will now separate the sediments and reduce the friction that is holding the sediments together. The water can also add to the amount of weight that is on the slope, and this can make the slope unstable. The materials will then be vulnerable and will easily be pulled down under the influence of gravity. Now, another situation is where the bedding planes are parallel to the slope surface. Under this condition, it becomes easier for the materials to slide along the bedding planes, especially if there is a layer of impermeable rock under the permeable layer. So during times of heavy rain, water will saturate the permeable layer at the top. But when it soaks down to the bedding plane, where the permeable layer meets the impermeable layer, it is unable to percolate any further, and therefore the top layer will slide off the impermeable layer under the influence of gravity. Now, landslides can do a great deal of damage, and therefore this is one of the hazards that we also study. Landslides can wipe out forest lands on slopes. They can dam up or flood streams at the foot of slopes. They can destroy agricultural crops along the slopes. They can damage built infrastructure on the slope as well as below the slope. They can also cause loss of life and social disruption. And of course, landslides can also trigger other hazards just like they can be triggered by other hazards. So, to mitigate against landslide, there are a number of strategies that can be applied. For example, planting trees and shrubs on hillsides to keep the soil packed and protected, or to even manage the existing vegetation along the slope. We can build retaining walls, which include concrete walls as well as gabion wall. This is placed at the foot of the slope to make it more stable. Catch nets made of cable and wire mesh can be used along the slope to catch falling rock at the bottom of rocky slopes, and this will help to protect roads and other structures at the foot of the slope. Now, since water is a main factor in landslides, one way to reduce landslide is by improving surface and subsurface drainage at the site to increase the stability of landslide-prone slope. In fact, one way to make retaining walls more effective is by using proper drainage along with it. Terracing or benching consists of converting a steep slope in a series of step-like structures. This can be used to slow down and drain away runoff during heavy rainfall events, and this will counteract the tendency of sliding, for sliding. Now, besides landslides, there are also other processes of mass wasting. And another type that we study based on our syllabus is soil creep. Soil creep may be defined as the slow, imperceptible movement of soil down a slope under the influence of gravity. Soil creeps are generally the result of the expansion and contraction of the soil on the slope. In tropical marine climate, the soil may expand during the wet season and shrink back down in the dry season. In the diagram, the blue arrows show the expansion of the soil, while the black arrows show how they shrink back. Notice that when the soil shrinks back, it does not return to its original position. Instead, it is pulled a little distance down the slope under the influence of gravity. So the soil is slowly being moved down the slope. The process is, however, so slow that we cannot see it when it is occurring. It's not like landslide. And therefore, we need to look for evidences to know that it is occurring. These evidences include the presence of ripples in the soil called terracets, bent tree trunks, tilted fences, tilted utility poles, broken retaining walls, tension cracks in the roads, and so on. Most of the materials carried down the slope during the process of mass wasting are created when rocks break up without being transported. This is known as weathering. Weathering may be classified as physical, chemical, or biological weathering. Chemical weathering is common in humid tropical regions like the Caribbean. One type of chemical weathering process is hydrolysis, which occurs when water reacts with silicate minerals. Silicates comprise almost all minerals in igneous rocks and are also important components in metamorphic rocks. The map to the right shows the Eastern Caribbean region. The islands of the inner arc are mainly made up of volcanic rocks. These places also receive a lot of rainfall during the wet season, especially as a result of easterly waves. So this is the perfect combination for hydrolysis to occur. During the process of hydrolysis, water reacts with silicates in rocks, such as feldspar, to produce clay. Clay is therefore present in many places within the Caribbean region, not only the Eastern Caribbean. Now, if we notice, the outer arc of the Eastern Caribbean consists of islands made up of limestone rocks. Besides these, there are other places in the Caribbean with large portions of limestone. Other places include Barbados, Jamaica, Puerto Rico, and so on. Limestone covers almost 70% of Jamaica's surface, as shown by the map. This results in the country subjected to a chemical weathering process called carbonation. Carbonation involves a chemical reaction between carbonic acid and limestone. Carbonic acid is naturally created when water combines with carbon dioxide. When the carbonic acid reacts with the calcium carbonate in the limestone, it results in the very soluble calcium bicarbonate, which is highly susceptible to the process of solution. Due to the permeable nature of limestone, due to the permeable nature of limestone rocks, a whole river can disappear through a swallow hole and continue its flow beneath the surface. This river that flows beneath the surface is called a subterranean stream, or we can also use the term subsurface stream. Now, if the subterranean or subsurface stream later reappears at the surface, it is known as a resurgence stream. As rivers flow beneath the surface, it sometimes contributes to the development of caves. Within limestone caves, features collectively called speleothems are formed. They result from the process of carbonation being reversed. They therefore occur where the solution being carried down into the cave experience evaporation, and when the water evaporates, it leaves behind the calcium carbonate deposit on the ceiling of the cave as well as on the floor of the cave. If this deposit occurs on the ceiling of the cave, it forms stalactite, and if it occurs on the floor of the cave, it forms a stalagmite. And if the two meet, then it results in the formation of a pillar. When rivers disappear beneath the surface, they leave the valley behind, void of water. This is known as a dry valley. In some cases, the water table may rise to the surface, that is, during wet seasons, so that water will flow temporarily within these valleys. Of course, during the dry season, the water table may fall again, and then the valley will become dry once more. The surface of limestone is not only characterized by a general absence of surface streams, but also by the presence of depressions ranging in sizes. In order of size, from smallest to largest, limestone depressions include sinkholes, dolines, uvalas, and pulges. Other surface features that are formed on limestone surface include limestone pavement, which is made up of grikes and clints, cockpits, which are made up of depressions and conical hills, as well as tower karst, which consist of steep hills separated by plains. All right, if you want to learn a little bit more about that, I will also leave a link in the description box. All right, so this is where we will end this video for now. I request again that you like, share, and subscribe. All the best in your exams.